So the test is, in this video the test is about Cauchy integral test. So Cauchy integral test, the statement is if fx is a positive integral and monotonically decreasing function on the interval 1 to infinity. 1 basically represents the first term of the given series. Okay, if it is starting from the 1, n is equal to 1 to infinity, then it will be 1 to infinity. If it is starting from n is equal to 2 to infinity, like we have in the case of log 1 by log n, then it will be 2 to infinity, like that. So it basically 1 represents the first term from which we are starting, from which the series is starting. Okay, with fx is equal to un, then the series summation n is equal to 1 to infinity un is convergent if integral 1 to infinity fx converges, and the given series will be divergent if the integral of fx is divergent. Okay, so don't get confused with this 1 to infinity. 1 is basically the first term from which the series is starting. Okay, so the example for that is summation n is equal to 1 to infinity 1 divided by n square plus 1. So the un is equal to, here un is already given in the equation, so we don't need to find out the un. So the time is saved. The un is n square plus 1, and like in this method we have to take fx equal to un, that is we replace x by n basically. Okay, so then from that we can say that here the fx function is 1 by x square plus 1, and you can see that x square we have in that, and there is no negative term, so it will be the positive. That is clearly visible that fx is a positive term. It will always be positive for every value of x. Now it is integrable also, and it is monotonically decreasing. Okay, monotonically decreasing function, so we can say that it is monotonically decreasing function. You can find that out also. There is a trick also you can try, that fx is in some of the question. You can try that. You have to do in some question, not here. Here you can see easily, but in some question that where it is difficult to see that the function is decreasing or increasing, it is very confusing. So what you can do, you can write down the fx, then you can find out the f dash x. Okay, and find out the values of basically x. If we have 2 degree variable, then it will be quadratic form, and we have 2 rows, and on by checking on the f double dash x, you can see that on which value it is decreasing. So from that you can say that it is decreasing in this interval. So this is also a trick. It works only for few questions, not for all. Okay, for few questions. So I'll just rub that because it only work for few, not whole. Okay, so it will be, oh no, yeah, thing. Okay, so it will be the monotonically decreasing function. So if we consider the integral 1 to infinity 1 by x square plus 1 dx, then it will be equal to, the integral of this is tan inverse x 1 to infinity, it will be equal to tan inverse infinity minus tan inverse 1. Okay, so tan inverse infinity is equal to pi by 2 and tan inverse 1 is equal to pi by 4, so the answer will be pi by 4, and this term is the finite term. Okay, which is finite. Pi by 4 is finite, so we can say that which is finite. So finite, it means it is convergent, right? So hence the function 1 by x square plus 1 dx converges because we are getting a finite value. So the given series n is equal to 1 to infinity 1 by n square plus 1 also converges. Okay, so this is the example for the convergent. Now I'll give you one more example. So example 2, we have example 2, we have n is equal to 2 to infinity 1 by n log n. So in that if you see the un is, what is un is given in the equation, it is n log n. Okay, so the function is, let the function will be what, 1 by x log x. Okay, so 1 by x log x, it will be, you can see that it will be, this function is positive, it's positive because we are starting from 2, it is positive, integrable and monotonically decreasing also, monotonically decreasing function. So we can apply the integral test here. So if you consider 2 to infinity 1 by, basically you can consider that 2 to infinity, like here I am taking the 2, so 1 by x log x dx is equal to log infinity minus log 2, so it will become out infinity. So as we are getting the infinity, that means it is not convergent, it is, that is the function, the integral of the function is divergent. So therefore from this integral test, according to this integral test, the given series is divergent. Okay, so that's all for today's video. Thank you for watching the video.